Steve. Welcome to the channel. As we start, can you please
Thank you.
introduce yourself for the audience?
All right. Thank you. Hi, thanks Vikas for this. Yeah, so my name is Stephen Oladele. I'm a data scientist and I also design non-profits, excuse me please. Uh, Beyond that, I've had a couple of years of experience in data science. It's about 4 or 5 years of experience in data science, from internship to leading data science teams, and currently just pretty much being a consultant, which is what I love, flexibility of that. I also do involve myself in training and development on the IT area. So, designing learning curriculums for very technical contents like data science, mostly data science and machine learning courses for companies that want to offer them either as a product or to their employees, and to really help make them more data literate, and of course help upskill their employees in cloud and machine learning, to really bring more value to business when it comes to having the right talents in the organization to keep helping their business grow. So that's just pretty much what I've been doing inside. I've had a little bit of experience in the academia, working with researchers in the PhD domain on very interesting topics like precision farming, entomology, also areas like the health science, and those are pretty much the areas in the academia I've had research experience with. So beyond that, I'm just yeah, I'm still like a couple of years into it, should I say? Don't have like a decade of experience here, for it's been a really exciting journey.
That's nice. So it's interesting journey you have. You have been working in data science for quite some time, and you said you're also worked on some other non-professional projects for helping people. Some kind of uh, in your LinkedIn profile, you say by the day you are a data scientist, and by night you're kind of helping people. Can you tell us more about how do you do it?
Yeah, no.
Yeah.
Yeah, it's quite tough, but kind of career in data science. Just kind of 1 year into my data science career, I realized we had communities for other technologies like Android. Everyone who loved Android back then could meet up with themselves. Website development. They're all very awesome, cool technologies back then. But um, there was hardly any community for data science in my city back then. So that kind of piqued my interest into seeing how we could do things. So we kind of started out as just like people who just were very people who just kind of loved the idea of just meeting together, seeing how much we can learn together, and so on. And then it kind of went from just being a couple of people who loved data science and we're just getting started in data science to larger community, and that kind of caught a lot of people's attention in the city, and that kind of went on from there. So 2 years down the line now, it's been really good. 2 3 years down the line now, should we say, it's probably almost 3 years now. It's been really good, and it's even we're kind of looking at taking it to the next level, just in terms of the design and making sure that it's a proper, sustainable nonprofit that we are solving. Challenges beyond just helping people learn and connect with data science practitioners, but also really helping people to take advantage of the opportunities in data science, either for upskilling themselves to be, job ready, or generally just being able to easily find a job through the community network, or being able to solve very, very interesting social challenges. And so these are the things that we're looking out for going forward. And even as a nonprofit, we've mostly focused on trying to get underrepresented people. So because that was the so core reason for starting out the community in the first place. People were not really represented in data science in the city back then. So we we've always, as we've gone on in the community, we've tried to expand our definition of underrepresented to even include people with disabilities because there are a couple of them there in our city. So it's something we've just been working on about the last couple of years, and we're really excited that we are taking that going forward. And beyond that, I mean, I used to also work with nonprofits as well, just helping them design their proper structure so that they understand that this is the impact they're going to work on and we're going to achieve. And then this is how technology can also help us achieve such impact. So how can we enable our stakeholders with technology? How can we enable our cause per se with technology? And so these are the things I also do as well. Non-paid, of course, because it's really exciting when you see nonprofits solving problems and sustainable development goals. That's the SDG goals, and it's always something that excites me a lot. And yeah, so that's what I do by night. On the weekends, I just try to do a little bit of writing and creating podcast shows, even though that's been quite some time now because of this and because of hectic work. But beyond that, I just try also kind of run a startup on the side with my colleague. So the startup is called Arc Server. So what we are trying to build there is trying to build a knowledge base for farmers, regardless of where they are or what device they have, or even what language they speak. So they have like a forum where they get to share knowledge if they are, if they can have access to the internet, fine. It's just like a Quora for smallholder farmers. They get to go up there in the forum to ask questions, get responses, get their newsfeed personalized to them, get the necessary opportunities surfaced to them, through proper recommendation and personalization and so forth. And then we have the offline product where we understand that majority of the smallholder farmers in Africa are in the rural areas where they don't have access to electricity, they lack access to electricity per se. It's not so they don't have, or they also lack access to quality internet or like no internet at all, and their phones are probably not internet enabled or things like that. So how could we include these people? As I mentioned, I've always been all about inclusive, and democratization, making things accessible. So it was really an exciting problem I have to take on with my colleague on how we could include people in the rural areas. And that was also one thing I saw that machine learning was capable of doing with great technologies like SMS aggregators. Now you can easily help people by through language models, for example, translating people's languages into languages that experts can understand. And once experts understand those languages, maybe they're asking a question for, how to should they do this in their native language. Having to take that native language and be able to translate that for an expert to answer, and then they get their responses back in their native language. Is really what excites me a lot, without having to have a phone that has access to the internet, and where they are is pretty much so far they can just get that network reception into their cellular phone, and they can be able to send message and receive message. They get to send their question in their native language, and they get to receive the response to the question in the native language, using machine learning and optimization, research algorithms that work on the back end to try to match them with the right experts to really answer your question. Is really something that really excites me a lot. And as I mentioned, it's always been about technology for good for me. Yeah, so that's just a bit of my adventure over a week.
That's interesting. So have you made this product or you're working on it? For the
Also,
farmers?
we're currently working on it.
Okay.
Yeah, so we've kind of launched our online products. So right now we are working with Vonage, and we're also working on AWS as well. So we're just building the language model based
Okay.
on breadth now, mostly, and okay, also working with the research. It's pretty hard because in Africa right here, the languages are very, very low resource languages. They're low resource languages, so it's always very hard to really push these things out quickly enough because there's hardly any quality data set out there for you to work on. But
Okay.
there's really amazing research going on space right now, especially for low resource languages. And we're really excited about the research going on there. I'm really happy that we are contributing in some way. And we're also happy about the progress being made by, free communities like
Mhm.
Mishanke and OP Africa, and some other researchers who are working really, really hard to make sure that lots of languages in the African sector, because Africa has so many languages, like a varying amount of languages, like it's hard to really keep up. You have languages that are almost extinct. You have languages that have little to no resources backing them up, digitizing them per se. So it's always very, very difficult to really make this work. And we've been trying our very best. That we've been working with researchers to ensure that the breakthrough, the advances in the low resource language space can also be transcribed into something that can help, say, for example, a section, which is of course smallholder farmers, to really enable them per se. So we take that research and we see how we can apply that and then give quality feedback to the researchers doing the work there. So that's where we are right now with the offline version, and consistently seeing how we can take that research, apply that while working with the farmers themselves to really understand, is this technology like what you want? It's kind of cool designing the technology with the farmers to ensure that it's also a technology that they can embrace, to find innovative ways to help them embrace it, and really so on. So right now it's still currently in stealth, for because obviously it's pretty hard to really get language models to work for low resource languages now. But I think in a couple of years, being very optimistic about the rate of exponential growth in research for low resource languages. I think we should be seeing it enable a lot of African regions where language barrier is a huge, huge problem. And of course, with SMS technologies being very useful, say for Natch API or Twilio, I think it's becoming really, really possible to get the Africans that are otherwise in areas where the internet may not be able to democratize access to information and and knowledge, and and the ability to succeed to them there.
That's interesting. So, how did you think of this project? You had some problem that you saw, or
Oh, okay. All right. So thanks for the question. The project was I won't like take credit for it. So the project was actually a second degree thesis of my colleague, who is also my co-founder, Emmanuel. So he applied to Cornell University right here from Nigeria with the project idea. He got accepted into Cornell University. That was back then during the COVID-19 outbreak and everything. Unfortunately, he couldn't just join the cohort. I'm sorry, not the cohort. That's the admissions back then, because it was pretty hard to get funding to really complete the entire process, because it was a COVID-19 period, and most of his access of funding was way out of reach. So rather than giving up on the idea back then, or having to wait another year to apply and everything, so he just kind of reached out to people he thought were like really good in the reasonably good in the data science and machine learning space, which of course is where natural language processing skills can mostly be found as well, beyond just linguistics engineering and so forth. So that was how we, got started, because, and obviously it was like, he when he pitched the idea to me, it was really, really easy to convince. I was really easy to convince, sorry, because I already was doing a couple of work in the nonprofit space, and then you could tell me that, oh, there's a way to democratize access to information to farmers, regardless of where they are, or what device they use, or where they live, or what language they speak. So that was a very, very interesting problem for me to kind of take on. And it's sort of like set out as a social good project, which of course is going to be is probably going to be yeah, it's definitely going to be going into the for profits, the business space. For the important thing is that the farmers are they should I say they're satisfied, and I know, and they're and the product really reaches them and impacts their lives. So yeah, that's it.
that's interesting. It's nice. Very few people really do something for the society. And- But one thing I must say that since I
Okay.
started this project, I have met a few friends in Nigeria, and all of them are really doing something for the society. It's very interesting. Most of the other people I've met, they are doing great job, but something specific in the industry. But everyone I met in Nigeria
Yeah.
is doing something for the society, and they're really happy to share the information. That's a really interesting thing that I've seen.
Yeah.
It's really nice.
Yeah, thank you. Yeah, I think everyone wants to, at least the majority of people here, especially the very educated people, they always want to find a way to give back because it's always very tough growing up here.
Mhm.
It's always, I mean, if you find a way to make something your life a little bit more meaningful, you'll definitely be propelled to find some ways to give back. Anyways, if you grow up with the right mindset and the right culture, which is what a couple of people, majority of people kind of do here, educated people anyway. So it's always looking at how they could give back while they found themselves in a reasonably successful area. So that's one of the things that kind of support that as well. Always finding ways to see how we could give back because we've been there before. We've been in
Mm.
areas where it's not been comfortable, it's not been and then we understand what it takes to really strive and work hard and just try to be a sport. But then again, that I think that's one thing that really excites people, the fact that they can see that, oh, I'm trying to help out people in this situation I wasn't before, and then here we are.
That's nice. Okay, then coming over to data
Thank
science
you.
and your current job, like what kind of work do you do in a data science job? Like how is it? How is your day? What kind of work is expected of a data scientist?
All right. All right, so I would say it's a bit non-technical and technical. For the technical side, I mostly do talent evaluation. That's for a company. I mostly do talent evaluation. So what the company does is they kind of match data science talents with they kind of match data science talents with recruiters. So I'm mostly on the back end trying to, see who is worthwhile to be on the platform. It's just like top, but who is worthwhile to be on the platform. What data science talent is meant to be up there. What have they worked on? Are they kind of worthy? Can they fit into this what particular profile do they fit in? What particular company can they work with? So that's the non-technical side of things. Well, the technical side of things, it could be really a very amount of problems. So I'm currently working on platformizing data science. So when we're platformizing data science, it's like you're trying to build the end-to-end platform for a business problem per se that can really help them scale, or if they are using, for example, you're trying to set up to make sure that they can use platforms like Kubeflow or generally just be their own custom platform on either their on-premise servers or they're using like AWS cloud or using Ivory Cloud, and how can you ensure that you're building the proper end-to-end reproducible pipeline for them to be able to take their data into it. Their data scientists can easily build models, can easily ship those models to production for rapid prototyping, and then can can get the necessary feedback they want on the model, how the models are doing, without having to incur extra technical depth again. So this is currently the area I'm working on. But prior to this time, it's mostly been about multi-domain specific areas. So sometimes there are clients that can bring in projects for the financial technology space, where you have like you get to work with financial data, get to see how you can model. Some of these get into production, like very little, like very few of them anyways get into production. Most of them are more like exploratory projects where that's the stakeholders just want the feedback quickly, and that's how you get to be in the data science space. Not everything you build will get to production, especially when you're not working. When you're working with companies that are not necessarily consumer facing intensive, like not all their business processes consumer facing, because you get to work on projects that really help stakeholders understand things on the internal side, and then most external facing projects you rarely get to even deploy them, because obviously there are lots of things surrounding sort of deployments. For example, when you build models and it's black box. It's really a black box. You can explain what's going on. It's going to be very, very difficult to put it out there because regulators and everything, that becomes very, very, very hard to really put into production. And then you have to find ways to build simpler versions and see how you can support the business logic until you can be able to build something worthwhile. So, but in other cases, you can easily build something and kind of deploy. And one of the problems I had, while starting out is that it's always very difficult. I mean, it's really a common problem with data science. It's always very difficult to get those models you kind of build in-house, on your Jupyter notebooks to production settings, so where they can actually work, where they can scale, peak number of requests. So yeah, lots of times where you probably are good enough deploying on a particular single machine or particular single hardware or things like that. But then again, that might not be enough because I think I've definitely seen cases where I never really expected the number of traffic to hit a model that we kind of deployed as a service. Then it was getting the number of a really good number of REST API calls to it. That's from the downstream system there. And then you get to see that there was a sudden time where there was just a sudden outage. Why was there a sudden outage? Because there was a peak, and the peak was mostly caused by a failed a failed upstream system itself. So all of these things you never get to, and you have to just kind of plan for them in production, because there are going to be problems you face with the system itself, and then going to be problems you face with the external side. So you don't know when there are going to be like lots of customer requests, or you might not anticipate for that already, or client requests going to your model if you're deploying, or if you say you want to also think about deploying on edge devices as well. What's the rationale behind it? And there are lots of decisions that have to be they are also purely non-technical that you have to take in the data science space. So yeah, also it's a kind of big world in its own. And I think I'll sound very, very cliche and mundane if I say it really doesn't stop at the Jupyter notebook models you build, not your understanding of the models you build per se as well. It doesn't really stop at that. Well, there are a lot of other non-technical decisions you really have to make. Or case in point, what sort of architecture would you want to build? That has to be planned before time. Or when you talk about your architecture, the architectural, the system of your architecture and things like that, would you want to just go for a platform that's ready made already, and just make your deployment there, which is going to be a lot easier? Or if your problem is more complicated than having to use a platform and you want to build yours yourself and everything, what's the rationale behind building it? Do you have the budget? Yeah, these are very, very key ideas. And of course, if you're lucky enough to be in a team where some people are already thinking about this problem before you, and all you have to do is really just work on the models, that's okay as well. But understanding that you also have to, beyond just trying to build models as well, you also have to interface very, very well with the team, because eventually you also have to think about where your models will end up. What are they going to do? What's the impact that they'll have, so that you can also be able to have that control over it. Because if you just build models and you don't have control over where they go or where they end up, it's always going to be very difficult, because obviously that if they are not tamed, if they are not managed properly, it's going to be very difficult for them to bring back the business value. And no one wants to hear that. At least I've been in corporate settings where nobody wants to get those excuses that you did your job and then it's not working anymore. It's not working the way that people expect it to work, because the lots of changes in the data, lots of environmental changes, the business climate has moved on slightly, especially during the pandemic area, where it was very, very disastrous anyways, for a couple of models that some customers and some clients built in production, and we really had to revert to using very, very pure business logic workflow to really get their systems back running, because it was very, very, very difficult for the kind of models to really keep up with that kind of changing dynamics. So that's a pretty hard one. And then that's where you kind of think about the fact that you may want to, if your system is customer facing, or at least it's not something you have to maintain. If it is, at least if it's something you have to maintain all the time to ensure that it keeps giving the right business value it was already set out to build for, then you have to start thinking about areas around what's called the popular machine learning operations now. So kind of operationalizing your models after deploying them, operationalizing them in production. And then, well, if it's not, of course, not customer facing, probably just something the stakeholders have to do, in-house. Then you have to think about, how well the results of your model, how well the results of your models will be kind of used by the stakeholders. What kind of decisions are they going to take with the models itself? So you also have to try to be in those conversations for, say, if they're talking about their financial, if they're trying to make a financial forecast, or things like that, what's the end result of that particular model? So you understand that this is that these are the risks, these are the trade-offs involved in using decisions on the model or not using decisions on the model. Probably you don't need to think about machine learning operations then. Maybe it's just a one-off project, or something that doesn't have to do with maintaining the particular model all the time. Or case in point, you probably might have to deal with if you've not done that already, you probably might have to deal with an external facing machine learning project at some point where he has to deal with a couple of customers, so probably even a million or more, so millions of customers would say, and then that's where the real trouble comes, because that's where machine learning isn't really machine learning, because it kind of integrates with a whole ecosystem of problems you have to deal with system engineering, system operations and production, trying to ensure that your systems don't break in production. How can you track this here and there? Because it's especially if you're working in a team or in a very small team, it's always going to be very, very, very difficult to get that right. So these are sort of like interesting areas. I wouldn't say it's one area, but it's more like a multi-domain area. So there's always a problem with the client, and then it's in a different domain from the one you worked on in the past month. I mean, sometimes some projects will take like 2 months, 3 months to sort of deliver. We've definitely had projects that are kind of span up to 7 months, and you don't work on these projects solely. You kind of work on them with from parallel. You're probably working on 3 projects at a time, and then you have like a product manager like trying to ensure that you're working on the right thing, and then you focusing your energy on something this week, and the next week you're trying to build the future feature for another model. And the thing with data science is that you always want to find a way to push out an MVP like really fast. No matter how poor that is, you just want to know how will this model do in production. So you always kind of think about, how can I get this model fast? How can I get the data? How can I explore the data? How can I run the data processing, if there's a need for feature engineering as well, and then, build necessary models. And you want to also get that into production. So that could be through a very, very basic Flask API service, just to see, what's coming in, just monitor it a little bit, what's coming in, what predictions are coming in from the live data in production. And then you see that kind of view that will probably give you insights on how you can improve the system there, and how much you can improve in your experimentation processes. So when you go back to development, what sort of models do you want to build that based on the insights you've gained on just the basic MVP you've put out there in production and things like that. So these are also things you might have to, just worry about, because I think it's always an anxious moment for data scientists when you tell them, look, you have to do a bit of software engineering hacking and to get your models from your Jupyter notebook or your very basic experimentation lab into a production environment. Now, yeah, of course, production environment varies by maturity. The way you get your models to production also varies by maturity and everything. But at the MVP stage, you want to get the minimum out there, so that you can really monitor that sort of situation. For say, a couple of the kind of data that comes into your model, and understand that, oh, this might probably not scale. If I build a full-fledged solution, this might not scale. So I need to understand, is the data worthwhile? Is there going to be things like your training seven skill, where the data you use to train your model in offline, that's in your Jupyter notebook, doesn't really tally with what you're seeing in production. And then you know for sure that if you're building a full-fledged solution, then that might actually be a red flag that you have to sort out before you eventually go all in and build a full-fledged project. So eventually, what I'm just trying to say is that occasionally, don't be afraid to just put something out there. I mean, there are lots of tools that really help you put something out there, at least as a service or as an API, service these days. So you could have things like Streamlit. Streamlit is getting a lot easier for data scientists to really use, and machine learning engineers as well. Of course, Flask is probably not very hard to learn. So you might also have to put away your anxiety for a couple of weekends, maybe a weekend or two, or maybe a week, and just try to see how you get. A Flask can really help you get your minimum viable product out there. But in the case of data science, of course, to see how a full-fledged system might behave in production just based on such experimentation, so that informs the insights of you and your team to see how you can best build a reasonably good model that's out there that you can kind of push out there that that will kind of be resilient enough for production environment, because the code and data is always going to be very separate. The rules and the data, sorry, is always going to be very separate, because the rules are what your models kind of form. So your models are like mathematical functions that fits onto your training data. But then when they get into production, they get slightly, they get to diverge, because the data is always changing, and then you don't have the rules keeping up with them. So you have to find a way to kind of tie those two together. That's the mathematical functions your model has learned already, and then the data in production to make sure that there's not that skew is it's kind of cut down on, or it's kind of reduced. So yeah, it's really exciting. But then again, the challenges are what you think. I mean, it's exciting when you build models and you're able to, it's also challenging as well. But then again, the fact that you can, do something that may not even get into production might just really help a couple of people in the department, to do their jobs properly. That's in the company, sorry, to do their jobs properly, or maybe a couple of people externally facing as well, to be able to, make better decisions and so forth. Is I think is what's fulfilling and what counts in this space.
Oh, that's good. So suppose if someone fresh out of college wants to join data science, or somebody wants to make a lateral move into data science, how should he start learning? Because there are too
Yeah.
many tutorials on the web, so people are confused. What is this starting point? How would you
Well,
say?
I would say that it's common. Yeah, I think I will just echo the common response, and that's really just work on projects. And it might be very difficult. Of course, obviously, you have to get the basics of data science under your belt, and that's where my first advice will come in, is that if you find a tutorial teaching the basics, maybe a lot of people love that particular tutorial. They just figure, it's a tutorial that kind of gives you the basics of data science, machine learning, and all of those other belts. Just stay on that path. Try as much as you can to finish the course and everything. If you're learning online, of course, anyways, if you're using online resources to learn, because that's where that has been the most prevalent way of learning these days, beyond just postgraduate studies or things like that. So if you find a course where that gives you the basic knowledge per se of what the whole data science space looks like. I advise you to stay on the course, because most people find out that they are halfway into a course and they're not really enjoying it much. But it's always going to be an urge to kind of jump off, and because you're not kind of seeing the immediate results. But I would urge you that you just stay on that path, get those basics right, and then because the thing is, data science is sort of like in phases, and the more you understand that these sort of phases are things you're going to be working on, it's going to be like a standard workflow, a standard practice you're going to work in. And the more you realize that there's already a standard way for you to learn, so you go about understanding the problem itself. And I think there's a really really useful technique that a friend of mine really used to get this under his belt. I really admire a lot and I envy. So he started out with understanding a bit of how business requirement gathering works. So how you talked about how you talk about what's it called now, problem statements, getting problem statements, working on problem statements, requirements gathering for businesses and so forth. So he kind of learned about that first. And after he's learned, of course, the basics of data science and everything, he went about learning about business gathering requirements. And he said, okay, I was going to learn about this and do a very very small project. So he kind of did a brief simulation as well after he took a particular course on just business requirements. He kind of did a brief simulation and of requirements gathering for like businesses and so forth, trying to understand that. Hey, when he kind of finished that off, he just made a blog post on it, kind of shared with us and say, "Oh, guys, what do you think about this?" And we read through that. It was more like he was applying the knowledge from the course he took on business requirements gathering itself. And then he also went on to do things like, how can I learn web scraping? And so that's like a very, very conventional path. How can I learn web scraping? He kind of learned web scraping, built a project there. He kind of went on to learn data exploration, that's data exploration analysis. Went on also build a project there using pandas. Was lucky enough to also get Tableau under his belt back then, build a visualization dashboard, and then also went on to doing a couple of things in feature engineering and modeling itself. So it kind of blends those together and then build a project there. But that's a very, very sequential path, and it's going to be very hard for people to follow that. So I'll always advise that if you get the basics under your belt, if you follow that particular useful book or that particular course and you've gotten that basics under your belt, I would always recommend Aurelian Giron's hands-on machine learning with scikit-learn book, especially if you understand Python. I'm assuming anyways that you understand Python itself. So definitely if you don't understand Python, just try to get the minimum, just be able to write the minimum like program with Python. You don't have to be an expert with that. Of course, just understand, the very basic things you need to do, like for loops, while loops, and your if else statements, and those basic syntax and those logic you need to be able to use to understand that, read Python successfully, because that's where you're going to put in a lot and more. The majority of data science is a standard process. So you have snippets for like everything. You have snippets on how to load your model. You have snippets on how you can exploit your data. You have snippets on, how you can, somebody out there has probably done some form of feature engineering you want to do as well. So just get the basics of Python under your belt, be patient with that as well. Make sure that you learn those basics properly. And then, beyond that, I mean, it's really just get the basics of ML as well, machine learning and all of those, whether it's through a book or, through a boot camp, you're going to learn that, or, through a particular online course. Just stick with that. And then when you're done with that, don't hesitate immediately to jump in and start thinking about the project you want to work on. So the best way to really get good at this, and the best way that employers can really validate that you have the skills without thinking about your lack of academic qualifications per se, will be how many projects you've worked on, and not just general projects like your Titanic projects, or Titanic survival, or very, very basic projects like house price prediction and all of those things. It has to be a very, very genuine problem you're trying to solve. So you see a problem, you see an area where it's ripe for machine learning, and the course is meant to tell you, is meant to teach you, that the basis of the particular course there is really meant to teach you what cannot solve, what machine learning can solve, what machine learning cannot solve. So if you really understand the dynamic of what data science can solve, what data science cannot solve, the pathway for data science, the CRISP DM, if you're in data mining, or the standard machine learning workflow or data science workflow, and then it's really all about thinking about what problems you want to then go on to solve. So it has to be very interesting problems. So don't get me wrong, not to say that you can't work on Titanic, you can work on house price prediction, or very generic solved problems out there. That would be those are very, very good stepping stones for you to do that. But also beyond that, start thinking about projects you will work on that are unique to you. So that could be maybe like, gathering COVID-19 data sets, COVID-19 information in your area, and then doing a very basic visual plot of, the number of cases. And so that's an exciting project you can decide to work on, because now you've thought about the problem, you started applying data science, of course. You've thought about the problem, which is analyze a particular problem, you've gone around collecting the data, and then you've done your visualization itself. For very, very, more intense problems, you might want to think about how machine learning can solve some pattern matching problems that you think you're seeing as well. So as much as you can, please just work on projects, but ensure that the bare minimum the basic course can give to you should really tell you this is the entire like phases of that happens. This is pretty much what you're going to be doing in machine learning, what you're going to be doing in this in science. And these are sort of this is the way to identify what a problem that machine learning can solve, and a problem you cannot solve. And then you can just go on and start thinking about the problems you can solve in your domain. And then other things I would advise is that find people in the industry who are also willing to help guide you, because that's always a problem. People don't have guidance. Yeah, yeah. There's a, like you said, to your point, because there's a plethora of content out there, and people don't know how to use it. It's always going to be overwhelming per se. So find people who are willing to guide you through the process, and help you understand the mistakes you're making, and the mistakes and the things you're doing correctly, so that you it's always going to be very helpful. I think you should. It's also something you want to do. Don't be afraid to reach out to people on LinkedIn. For advice. Just basic coffee chats. It could be like, oh, can I get 5 minutes of your time to report some of my progress to you? Surprisingly, I mean, not surprisingly per se, but people could actually be really, really helpful if you just reach out to them on LinkedIn. It could just be like a small connection request with a note of somebody you admire a lot in data science who is actually doing, applied work, like practical work, because, some people could be influencers, and then some people could be doing actual data science work. So, find a way to find those people who are doing actual data science work. And maybe influencers as well may also help you out as well. For you also want to find people who are doing the applied work, so that you get more practical knowledge from them. And then get to ask, okay, this is my progress so far. I've already started data science, which I would recommend you do before you reach out to them anyway. I've finished this course. I'm thinking about this problem I'm trying to solve. How do I go about solving this problem? Yeah. Also, Quora is also an amazing platform for you to ask questions there. If you can find people who answer your questions, like more specifically, you have great people over at Quora who really love to answer your questions properly and so on. But it's always going to be valuable when you can have a 5 minute coffee chat with somebody who is doing data science work, and it's going to be exciting to really tell them about your project and how you can go on from there. So really hope it wasn't overwhelming, just like the amount of materials out there. But the basic summaries, get the basics under your belt. Get the if it's a book you're trying to read through, ensure that it's a good book anyways, because there are lots of recommended good books out there. I don't have to recommend anyone. Like I said, the one I'll probably highly recommend is Hands-on Machine Learning with Scikit-learn, which is a very, very useful book as well to get you up and running if you know Python. But then again, there are lots of really good tutorials that get you the basic, I mean, the bare minimum of what data science is. And some of them even walk you through projects, which I will also advise you should try doing as well. But immediately you finish that material, immediately you finish that resource, start thinking about problems you want to solve that are more unique to how you apply the data science knowledge as well. So it's application that we see, especially on the talent evaluation and the kind of requirements I get from companies as well in the company I work for is that they want people to have experience in the area they are already working on. So this could be like computer vision. They have like work that is specific to computer vision. So it's not like typical software engineering space where you could hire a software engineer regardless of whatever experience they have in whatever industry. They are just there to build the software, and that's just it. That might not be relevant. With data science, companies are beginning to be more specific on who they hire. So these are people who have probably worked on a use case that's similar to theirs. So that can give them an idea of what sort of scope of project this person has worked on, and how they can assess how they can work on a larger scope of project again, and things like that. So it's going to be more so about how you think about problems and approach solving the problems. So it's going to be valuable to companies, and not just I think beyond just the knowledge you gather from the resources you get. Yeah.
Okay, that's one thing. Like, another aspect of it is like I've seen some people who went into data science. I think I lost you.
No, I'm still with you. Sorry, just trying to.
Okay.
I'm still here. Yeah, sorry, I was just
Okay.
trying to get my seat the right height. Yeah.
Oh, yeah. So I was saying that And I've seen people who started with data science, but in a few months or years, they really got frustrated and they realized that this is not meant for me. I'm sure you have met such people as well.
Mm.
So, can you just point out
Yeah,
a few pain
yeah,
points
definitely.
of data science that people can be cautious before they start? Like, if they are going to be, if they are going to like it.
Yeah, so I actually do understand that it's a hype. There's a lot of hype right now in the data science space. It's not all glamorous and things like that. But data science is becoming a lot more accessible. I mean, with very you don't have to be an expert. You don't have to even be a guru to really be able to apply this science in your product. So I would always start with, what's the reason why you're learning? Are you learning to like do a thorough a thorough what's it called a thorough career change. Maybe you're switching from one career to another, or you're just learning because there's a problem you want to solve, and then there's a problem in your company you want to solve, or things like that. So maybe you have a specific reason why you're solving it. You're trying to learn the science. If there's a problem you want to solve already, and you feel that, oh, it's going to be an arduous task learning data science from scratch. I mean, there are lots of tools out there. You have AutoML tools, like automated machine learning tools. You have Google APIs or cloud APIs in general, like AWS and all of those things. So far, I think I would always go back and say is that the basic thing is that you get that basics under your belt. So you understand what machine learning can do, understand what machine learning cannot do. That gives you a direction, that gives you a sense of direction. So if you know that, oh, this is the basic problem I want to solve, it doesn't have to do with heavy technical expertise. I can just decide to just start using like very, very, pre-made tools like APIs to really solve my problem, or just using AutoML tools to really solve my problem. That kind of reduces the learning curve like a ton, and that helps you. That kind of increases your chances of success, because now you don't have to start learning like very, very technical things like Python, going to pandas, going to the very, very popular open source libraries, or not open source solutions per se, depending on what you're solving for. you know it really helps set you up. So if it's not that you have a career path already, or you just want to see how you could use machine learning to solve a particular problem. I mean, there are lots of tools out there that make it accessible. But for you that want to also do a proper career change, so you want to change like your career, or maybe you're in the computer science space already and you just want to focus on machine learning and things like that. What will really help out, as I mentioned again, is understand that these are the tools you have to work with and work on projects. It's going to be frustrating, but if you can get to work on the more projects you work on, I think the more projects you work on, and then I think the more confident you kind of feel per se in how you can really get. And of course, you're still going to doubt yourself and everything, the imposter syndrome and everything. But I think as you build projects and as you go on with that, you get to see that it's going to be a normal everyday thing. But in a case whereby you're stuck in tutorial hell, so from one tutorial, you've gone from one tutorial to another, and then you finish and you've just been getting a certificate or the completion exercise, and you've not really done anything with the knowledge you have, it's going to be very, very easy for you to veer off, because you're not working on interesting problems, you're not solving anything with the knowledge you have. So, but when you're solving problems with the knowledge you're gaining, I think it's going to be quite easy. It's going to increase your chances of staying longer, because if you're working on a problem 2 3 months and you're trying to get it, you're looking for a tutorial that teaches you this particular thing. There's a reason why you're going for a tutorial. It's going to be a lot easier for you to succeed, because obviously you have a reason you're learning this particular tutorial, and you're taking this particular course, or you're going through this particular book or this particular article, and so on. Then when you're just sporadically learning, so you just jump from one course, maybe you probably didn't finish the first course, and you jump into another course, and then down the line, it's a lot of work because you've now learned a lot of things, and then there's no way to apply them. So application is really king in the data science space. But first off, you really need to understand why you're actually getting into data science. Maybe you don't have to learn Python. Maybe very, very pre-made tools out there might be useful for you. And if you think that it's actually worthwhile to learn Python, maybe because you're doing a total career switch, and yeah, I mean, it's really all about thinking about application in any sense. Whether you're from a technical or non-technical background, I know it's very, very hard. It's going to be very hard for people in a coming from a non-technical background. But one thing I would also advise is that if you're coming from a non-technical background, also give yourself, excuse me, please, excuse me, sorry. Yeah, sorry. So if you're coming from the non-technical background, give yourself the chance to succeed by giving yourself very, very quick wins. So what I mean quick wins is that you could easily go to, I think there are free trials on the Google Cloud API platform. So see how that can solve your problem quickly. Like, think about a problem, think about, for example, your problem could be how to identify people wearing masks. You're trying to solve a problem for how to identify people wearing masks. So you could give yourself a quick win by just getting the images of people wearing masks, go try them out on the Google Cloud API and see if you can recognize that. That's a machine learning project. You don't have to build gigantic models to be able to call it machine learning. That's machine learning in some sense as well. So you can help yourself to succeed by giving yourself quick wins in that sense, so that when you understand that, oh, this is how it works, then so far that solves my problem. It's okay. I can still be learning machine learning on my own. I can still be learning how this works if I want to do a full career change anyways. But that's a good one. This is one small project I've worked on. It might not be like the best project ever, but I'm happy about the kind of outcome and everything. You could also go about, oh, I could use AutoML to do some very basic things. And then that's really going to keep you longer, because you have to understand that you got into the field because it was interesting in the first place. Now, if you got into the field before because of the hype and everything, or because of the money, which is also very common as well, which is guaranteed as well, which is okay as well. Understand that you also have to keep up that motivation, because eventually, if the money doesn't come as fast as you want, or if the hype dies off because you've seen how complex it is, the fact that you need to understand statistics, you need to understand SQL, you need to understand mathematics, because those are the applied areas you're going to be in the most. Not the deep learning and everything, unless you're working for like a little bit of established companies, or companies who actually know what they want, especially from machine learning to say. But beyond that, you probably are going to be using a lot of SQL stats and the basic models to really get things up and running for you. But yeah, I mean, it just has to do with why you actually got started in the first place, and really understand that if you started because you had a specific problem you want to solve in the industry you are already, then just know that there are a lot of tools that you don't have to write code for. There are low code solutions, no code solutions, in fact, to get your problem. I mean, there's teachable machine learning that you can do machine learning right from your browser. You can train the model right from your browser, and you don't have to write any code. So these are ways whereby you can, get yourself out and don't just get stuck into the loop of learning. It's a long-term thing. It's a long-term game. So it's not a couple of months. You don't get this in a couple of months. It's not even a couple of yeah. You just have to make sure that if you're in it, you understand that this is a career path I want to take, and just keep going at it. But then again, if you're from a non-technical background, like I said, try to give yourself small wins by doing some projects with pre-made tools already, and seeing the impact those projects have, and that will just keep you going and keep you motivated as you also try to work on your own projects that are more custom to some certain things. Even if you can't think of a problem you're trying to solve, just try as much as you can to enjoy the process. And it's going to be cliche when I say enjoy the process, because there are lots of things that could go wrong. You're trying to ensure that you have enough money to keep yourself learning. You're trying to ensure that there may probably lots of external pressure on you as well to learn, because obviously you have to do something for yourself and things like that. I totally understand that, and that might be frustrating a lot, but ensure that it gives you joy rather than pain. And data science should give you joy rather than pain. And the ways that you get joy is more so when you work on projects that are very interesting, and then when you're also applying what you're learning. Those are the things that give you the joy and give you the quick wins to sort of celebrate itself. But if you don't work on projects and you're just going from tutorial to tutorial, from book to book, from articles to articles, you're going to find it frustrated. You're really going to find it frustrating. Sorry.
Yeah, that's a nice point. You should go after quick wins, and it'll be, and you can keep your momentum going. That's an interesting point. Okay, that was a nice discussion on technology. One question apart from technology. Like, what are your hobbies apart from when you're not working on data science or on anything technical? What do you do? Or this is your passion and hobby itself?
Okay, yeah. As I mentioned, yeah, as I mentioned, beyond if I'm not working on data science and everything, I'm always trying to volunteer for things. So that's a
Okay.
non-profit courses. Sorry. If you go to my LinkedIn profile, I've done a lot of like non-profit
Yeah.
volunteering because it's something that excites me a lot. And now I'm also like a lifelong learner. I learn very, very abstract things. Recently, I started learning about wildlife, the Siberian tigers and everything. So I kind of learn sporadically. I kind of call myself a polymath, learning like different things. So beyond that, beyond technical things, I just want to learn about, be it wildlife, be it, just very random things that really, just keep me alive. I mean, learning is one thing that really keeps me excited and keeps me going as well. Beyond, of course, the non-profit design, I always want to just find myself learning and then friends. Spending time with friends as well is also a really good thing. You should definitely hold key, especially in the data science space, because if you could be very as you go on, as you what's it called, as you progress in data science, you find out that the problems you work on become very complex, and then you need to also spend some time away from your computer. I'm guilty because sometimes I work Mondays to Saturdays, or even probably Sundays itself, but it's not healthy. I find that I get frustrated the next week. I don't get to work on I don't get to be very productive the next week when I get to like use my entire week working on a particular project, because I really love when I really love when I get the project done at that time, not when I have a very difficult time and then I have to shift the project and maybe work on a new thing. It's always frustrating for me coming back to an old project. So I always try to see if I can just finish up the project in one go and everything, but it's not healthy because obviously if you can't finish at that time, you should always try to find a way to, step away from your computer. But yeah, beyond that, really, I totally understand that you want to spend a lot of your time on your computer, but just have an hobby outside, and that is going to help you a lot, especially in data science, where it's a multidisciplinary, multi-domain type of this thing. Just learn about other domains. It doesn't have to be. You don't have to have a reason for learning for that, for learning about them. For me, I didn't have a reason for picking on wildlife, at least in the past month or so, to really start learning about wildlife and everything. But it's fulfilling for me because at some point that knowledge will circle back in data science, in any sense and everything, because I just love just learning about different backgrounds, learning about health, learning about culture, learning about very basic, very different things that that not really particularly related to technology, and just outside the domain literature, just I just reading outside and reading outside of the scope of very technical distance. So that could be what you probably use your weekends to do. So that's how I kind of divide my life per se. So like my Mondays to like Fridays, I just walk, just pretty much just getting that under my belt. And then my weekends are just me just goofing around on say YouTube or Curiosity Stream, just learning about new documentaries, learning about, because documentaries are like one of the best ways for you to learn about other domains, because they are story immersive, so they immerse you inside the story per se. So you could do that, and then don't forget hang out with friends. Please go outside, get some fresh air, walk and try to exercise. It's very, very crucial. But, I mean, weekends should be like there for you to really help you get your hobbies and do stuff for yourself. Yeah. Not really. I think I've said a lot, and if I say more, it's going to be overwhelming. So I think the really learners, sorry, the viewers can, eventually try to roll with the points we've made so far as much as you can. Please, if you have to revisit this again, if you're watching it the first time, just ensuring that you pick out the vital points. So, but eventually it's going to be arduous. It's not going to be an easy journey. Just echoing the cliche term again, something that you should probably already know already, but it's not going to be an easy journey. But the most important thing is that you're working on very interesting things. So You just pick on problems you're working on that are very interesting. And then if you're sometimes you might be lucky enough to really get into companies that are also solving interesting problems as well. Do not take that for granted. And lastly, just be a very good human. Be kind to people, be kind to yourself. It's a process. Be kind to people as well. It's also a process for them, whether they are, acting good, acting bad, just be kind to them. That's what humanity is all about as well. You're solving problems for yourself, and then you're solving problems that will impact, even if it's just one person it's going to impact. That's also very, very key. So be kind to yourself and also be kind to the people in the society. And eventually we just want a better world. Whether technology or not, the skills, hard skills, the soft skills, really we want a better world. That's just it.